Hey there, Earth Science fans. It's Mr. Cole here, and today I'm going to model how the process of convection can cause continents to break apart. Now, this is like what happened during Pangea, but this is also what would happen anytime a continent broke apart over the course of Earth history. So, at the beginning of Earth's life, the whole planet was a giant ball of lava. So, to model that liquid rock or that lava, I'm going to use milk. So first we'll add the milk to the pan to symbolize all that melted rock that was there at the beginning of Earth's experience. And remember, it was lava because all the rocks crashing together in space, well, they crash together, and that creates a lot of friction, and that friction generates heat, which melts the rocks, turning the rock into lava. Next, to represent the crust, I'm going to use this hot cocoa powder, which will hopefully float. So over time, some of that liquid lava from the crust cooled off because space is really, really cold. So the outer layer would have cooled off into a solid like this. So let's add our crust and let's hope it floats, because I just tried it and it all sank. Then I had to go to the store and buy some more stuff. So, okay, so our crust is here. Should I add it all? Yeah, why not? Alright, so again, the outer layer of lava would have cooled off when it hit the coldness of space, and when lava cools off, it turns into rock. So here's our first continent on our model of Earth history. Alright, so there's our continent, and we're going to add heat from the core by turning on the stove. Nice. Alright. So this is representing heat that's in the core. Now, it's still hot inside the Earth, but all that heat originally came from that original melting, when all the rocks crashed together and melted, generating that friction. That's the heat that's still trapped inside the Earth, and there's other reasons why it's still hot, but so we got heat happening from the core. And on the surface, we'll watch and see what happens. We might have to wait a few seconds, but we'll check back in a little bit. So the first thing I notice is little chunks of the continent are falling off into the magma or the milk, which is kind of like the process of erosion. You know, gravity will pull rocks apart, or maybe rain will break them apart, or wind. So we have some erosion going on here. I didn't really expect to see that. I also notice in some cases the milk starting to move, but not too much significant movement. And some bubbles over here. So we'll check back in a second. Alright, so I'm seeing a little bit more bubbling. The milk is moving a little bit. Kind of. Some cases. There we go. Oh. So why is that milk moving? Well, it looks like it's rising up. Now, when you heat something up, right, we're adding heat to the milk that used to be cold here in the bottom of the pot. Well, when you change the temperature of something to heat it up, you decrease the density. Now we're seeing a lot of motion, and I wonder if it's going to boil over, which is not the point of the experiment, but okay. Well, so that's happening. Turning off the heat. Well, as I was saying, when you turn up the temperature and you heat a liquid, you cause the density to decrease. So the molecules speed up and they spread out, and that causes it to be lighter and rise to the top. So what we saw was the milk pushed up over the continent. So that would be like a huge volcanic eruption. And any volcanic eruption is caused by the same process too. When we have magma that's being heated, it becomes less dense and rises up. So we can see that rising milk there. Now again, this was gonna overflow and probably create a big mess. So this is not what I expected to happen, but I was trying to show you guys that convection happens when you heat up liquid, and that's what's happening inside the Earth. When you're heating up liquid magma, it rises up, and in some cases it pushes on the continent and breaks it apart. which is what I was expecting to see here. We did see rising liquid, and it almost rose up and spilled all over my kitchen. So again, convection was still at work, even though we didn't really see the continents breaking apart. But let's see if it's basically, I think it's just going to do the same thing. So I will upload a video of somebody successfully doing this. But still, there's convection, boom, rising up. So when you heat up liquid, and then those are kind of like little plates moving around. So again, this didn't dramatically show continents breaking up, but we do have like little fragments of continents here that are still floating on the surface. So this is what happened when Pangea broke apart. There was a big continent in the middle. The lava pushed up because of lower density, because of the process of convection, rising heat pushing on the continents, and broke the continents apart, separating them into the continents that we see today. All right, so there's a little bit of convection. I'll upload another video where this demo goes a little bit better. Oh, look, this is a little continent right there. All right, guys, well, thanks for tuning in, and I'll talk to you later.